In this video, I'm going to look at how to add vectors algebraically. And so remember from the last video, we had two vectors that were being added together, 50 newtons at an angle of 20 degrees plus 100 newtons at an angle of 130 degrees. And so I have drawn these. This would be our vector A down here. And the second one is vector B in green. So it's there, and we have our resultant in red. All right, so the basic rule for adding vectors is you must add by components. So we must add up the x components of each vector and get the resultant x component, and then we add up the y components of each vector to get the resultant y component. And the reason we're looking at this with the diagram is because visually we can see that happening. So let's take a look at, first of all, vector A. And vector A forms a little right triangle right here. And we know that this is 50 newtons. And we know that it is 20 degrees right here. So thinking back to trig, we want to find the x value. And I'm actually going to call that A sub x. All right, it's the x value of the A vector. And all of the x components are found by doing r cos theta. So we must multiply 50 times the cosine of theta, which is 20 degrees. And that value, I'm just going to round to 2 decimal places for this demonstration, is 46.98. Now that's also in newtons because that's a unit of the vector. Let's now work on the x component of the b vector. We'll do that one in green. This will be b sub x. So my x vector for the a went here and stops there. If we look at that, that is 46.98. Now the x component of the b vector goes from that same line, but it goes left, right? Correct? I mean, comes back like that. Well, mathematically, let's find out what that value is. And I want that to line up with just below here. So it's going to come right to there. All right. This will be 100 cosine 130 degrees. And on the calculator, that comes to be minus 64.28 newtons. Now the negative is because we're talking about an angle that is in quadrant 2 where cosine is negative. So that's why we get a negative value. So this is negative 64.28, telling us that it's going to the left. Now what happens if I add those two vectors together? They are both parallel, aren't they? One is going straight to the left, the other is going, to the right, and the other one's going to the left, and they're parallel. If we add them together, we get the sum of those two, which will end up like this. So adding those together, the r sub x is equal to 46.98 newtons plus negative 64.28 newtons, which is equal to minus 17.3 newtons. So there's minus 17.3 right there. Now I've made a mess of that drawing, but that is the horizontal forces of each of these vectors. Now we will do the same thing for the vertical. Okay, so this is the horizontal. Now we will do the vertical. And let's take a look. The a sub y, the y vector of the a. So that's right here. And y equals r sine theta. So the y vector of A is 17.10 newtons. Oh, let's write in how we get to it. 50 sine 20, which is 17.10 newtons. We'll do the same for the green. That's going to go from this height right here up. So we go from the horizontal, the x-axis, up to this level. Think of it like an elevator. And from the same level, from there, we are now going up to the very tip, okay? So the b sub y is 100 sine 130 degrees, and that number is 76.60 newtons. And when I add the two together, we've gone up that high, and then we've added to go all the way up here. The r sub y is 17.10 newtons plus 76.60 newtons, which is equal to 93.7 newtons. All right, so for the resultant vector, we have the x component and the y component. Now, if we know the x and the y, this one will be 93.7. We can calculate the r, which will be a hypotenuse, and we're going to have to find the angle. So I've just moved down here a little bit to redraw the resultant vector and its component vectors, the r sub x and the r sub y up here. Notice that that's a right triangle. So in order to find r will be equal to the square root of r sub x squared plus r sub y squared, which is equal to the square root of negative 17.3 squared plus 93.7 squared. And that comes out to 95.3 newtons. Be careful when you square a negative, it turns positive anyway, so you don't need to even put that in the calculator. Now the angle that we are looking for is in here. That tells us where to go from 0 degrees. However, when we first solve this, we will probably get the reference angle, which is alpha in there. So let's find alpha first. We will say that alpha is equal to the tan inverse of the y over x, right? Tan is y over x, so it's the tan inverse of y over x, 93.7 over negative 17.3. And that turns out to be negative 80 degrees if I just round it to a whole number. And so that's just telling us that we have a reference that alpha itself is 80 degrees. All right. I didn't really need the negative there. It is a negative direction, but for a reference angle, we take them as absolute value. So if that is 80 degrees, then the quadrant 2 angle is equal to 180 degrees minus 80 degrees, which is equal to 100 degrees. So our resultant vector, which is the sum of the two, is 95.3 newtons at an angle of 100 degrees. And that's it. That's how we find the sum. Thank you for watching.